very, very easily. Any questions? Okay, then it asks, how does the impact of the transformations, how does it change the domain, the range, the intervals of increase and decrease, and the turning points? Well, we can see it right on the new graph. Where's the new intervals of increase and decrease? They're now here. This is decrease, this is increase. Here's my new turning points. Does it affect the domain at all? Alex, what do you think?
Does it affect the domain?
Yeah.
No, because isn't it going on forever, so it's an element of all real numbers?
Right, so the domain's not affected. Good. Does it affect the range?
Yes, because the amplitude got changed.
Excellent. Perfect. Very good. Easy. Number 4, last one. Describe the order in which you would apply the transformations defined by this function now. A little bit more complicated. Let's see. Nicholas, over here. You're going to tell us what are the transformations going on.
There's a flip in the x-axis.
Okay.
It's vertically stretched by a factor of 2.
Yep.
It's horizontally compressed by a factor of 3.
Yep.
It's horizontally translated 1 unit to the left.
Good.
And vertically translated 4 units left.
Excellent. Now how do I go from this using this parent function? Who wants to try? I'm going to write it out. Okay, Joseph.
So you're going to put negative 2 in front.
Just go from the beginning. Y equals?
Okay, so y equals negative 2 and the square root of x plus 1, and that's under the, the square root of 3x plus 1. And then outside of the square root, it's going to be minus 4.
Very good. So I explained that fairly well then, right? Everything that's in brackets goes in for x. Kind of like a double substitution. That's going in for x, and then this is coming in here into the main equation. This is a 3. I'm going to rewrite this. Any questions there?
So the 4 is not part of the...
No, sorry. Thank you very much. Okay, then state the impact of the transformations on the domain, range, intervals of increase, and the end behaviors of the transform function. So, here you can see they've used that formula that we went over just in the last example. And see how easily they convert the points. Okay, and that allows them to graph it very quickly. All right, so great to remember this formula. Where is it? This formula right here, x over k. So I'm writing it down again here, ay plus c. Okay, so they're using the value of x, which is 0, they're putting it over k, which is 3 here. They're multiplying it by, x value is 0. So they multiply it by 0, and then minus 2, which is the a value, times y, which is again 0. So it's 0, 0. Let's do it with 1, 1. Make a little more sense. So 1 over 3, so there's our x value over the k value, which is 3. Times the x value, which is 1, so x being 1, plus d, there's no d value. Oh, sorry, there is a d value. The d value should be plus 1 here. Oh, they haven't done the transformation yet. They're just doing the stretched and compressed. Okay, I'm sorry. Here's the final transform function. All right, so here they do it all. All right? They're doing them one step at a time. I'm not sure why. You could go from right from here to the final transform point. Okay? So this formula should give us these values here. So let's try it. We're going to use 3 and 6. Okay? So 3 is my x value. We're going to use... Oh, thank you. So we're going to use 3 and 6 and sub into here. So we're going to have 3 over our k value, which is 3, plus our d value, which is 1, comma, our a value, which is -2, times -6, plus our c value, which is -4. So 3 over 3 is 1 plus 1. This gives us 2, comma, -2 times -6 is 12, minus 4 is 8. Something's wrong. Positive. -2. Positive 12. I got 2, 8. Somebody see where may have went wrong?
It should be -8 if anything.
Sorry, no, -2.
Times, oh no, that's, yeah, that's 8, yeah, no, fine.
Something's wrong though.
Yeah.
Definitely wrong here. I'm gonna have to look at that and come back to it and see why. Something's wrong. This formula is not working. The book, this is correct though, because you can see the graph is gonna be flipped, so it definitely should be negative.
They just didn't multiply by -2.
So they had -6 plus -4, yeah.
So they already did it in the first chart.
Oh, I see. Yeah, you're right. I used the transform point already. That's what happens when you skip too many steps. Okay, yeah, because they went kind of two-step method, I used their transformed point, the stretch to compress transform point. So it was just a coincidence that this worked out. Anyways, you can go from the original point to this point. Okay? Take my word for it. If you have any problems with this, come see me. I'll correct you. Okay, but here's the final transform function. That was the issue though. All right? So finally, in summary, transformations on a function must be performed in a particular order. So here it is. Horizontal and vertical stretches compressions first, including any reflections, must be performed before translations. All points on the graph of the parent function y equals f of x are changed as follows. So here, there's that equation I was attempting to use. Again, the reason why it didn't work in the last example was simply because I used a point that they had already transformed. They already applied the stretch to. Okay, that's why it wasn't working. When using transformations to graph, you can apply a and k together and then c and d together to get the desired graph in the fewest number of steps. So this is what I did at the very beginning. Once I made the substitutions into the parent function, I canceled the a and k values. Remember when we had 2, it was like 2 over 0.5, I said this was 4. Okay, this makes fewer steps. Okay, so remember this and use it if you can. It's going to save you a lot of time. So you need to know the value that determines whether it's a vertical or stretch or compression or reflection in the x-axis. When a is greater than 1, it's a stretch. When a is between 0 and 1, it's a compression. And when a is less than 0, the graph's reflected in x. We all know that. For k, when k is greater than 1, the graph is compressed. When k is between 0 and 1, or a fraction, the graph is stretched. So we talked about this as well. When k is less than 0, it's also reflected in the y-axis. Okay, so you can have reflection in both axes. The value of d determines whether it's horizontal, and the value of c determines whether it's vertical. Okay, any last questions? All right.